Okay, calculus students, I'm going to make this video today since I'm unable to be at school today. Just kind of discussing the FRQ questions. Okay, so these are the FRQ questions on your final exam review. I'm going to go through them question by question. So I'm attempting to make this video from at home, so I know it's not perfect. But I've got this set up here where you can see me write, and I'm going to discuss the questions. So first we're going to look at number 2. Question number 2 is asking you, it's giving you an equation here, and it's telling you that at t equals 7,000, q of t is 150. And what this is a amount of a substance. This formula models an amount of a substance where q sub 0 is the initial amount. And it's asking you to actually find what the initial amount is given this information here. So believe it or not, this is actually a pure algebra question, honestly. We know that Q of T is 150. We know that's the amount of substance after 7,000. I believe the unit was years. We don't know Q sub 0, but we know that the time is 7,000. And we've got that times this decimal right here, negative 0.0001 times 7,000. So we end up with, once we plug in, we end up with that. And the only unknown in this equation now is that. But we're going to have to solve this as an exponent, like an exponents equation. So we're going to have to use basic logs, most likely, to help us solve this equation at some point. So what we can do, real quick, we can do 7,000 times that decimal right there, that negative 0.0001. And that's basically, when you do that, you're going to get 150 is equal to q sub 0 times e to the negative 0.7 power. Actually, we won't have to use a logarithm. I don't know why I said that. Since our variable is not in the power, because t was our variable, sure, up there, but t is, we know time, we know what this is, we're solving for q sub 0, so all we really have to do here, guys, is divide both sides by e to the negative 0.7 power, and that's going to get our q sub 0. So we take 150 divided by e to the negative 0.7 power, and that gives us q sub 0 to be approximately 302. And you would want to use the units, which I believe are grams. I could be incorrect on that, but put your units on there as well with this problem. I'm unable to look at I don't have a printout of the questions, so I had to write this all down from the problems on the document that I've got, digital document I've got, and so that's why this is a little bit challenging to make this video, but hopefully that makes sense. Just make sure you put your units on there, and then answer the question that the initial amount of substance present is 302 whatever units. Okay. All right, so that answers that question. Let's move on to number 3. On number 3, they give you a function. It's a nice rational function. 120,000 divided by 1 plus e to the negative 0.3 t power. And then what they're wanting is the rate at 10. So this is a population growth function, I believe. And they're wanting you to find the rate that the population is changing by in 10 years. So what you're looking, rate of change, rate is a key word there. It's talking about a derivative. We're basically finding the derivative at 10. So we need to find the derivative of this function first. So p prime of t is going to equal we will have to quotient rule this. So we'll say bottom times the derivative of the top. The derivative of the top is 0. Yay, that makes that life easier there. Minus not equals, minus the top times the derivative of the bottom. Derivative of the bottom, derivative of 1, 0. Derivative of e to the negative 0.3t is negative 0.3 e to the negative 0.3t. Because you have to kind of chain rule that. E to the u, derivative of e to the u is e to the u times the derivative of u with respect to x, or in this case t. So that's where the negative 0.3 comes in, because that's the derivative of that power. And all that is going to be over the bottom quantity squared. All right, so cleaning up we can do here, all this right here is going to go to 0. On this term, 0 times all this is 0. So I'm going to have a negative 120,000 times negative 0.3. That's that's a positive 36,000 times e to the negative 0.3t. And that's all over the quantity 1 plus e to the negative 0.3t, all of that being squared. And now we're ready to find this. This is our p prime of t. So we're ready to find p prime of 10. We evaluate this at 10 using our calculator. That's going to be 36,000 times e to the negative 0.3 times 10 power 10, all over 1 plus the quantity 1 plus e to the negative 0.3 times 10, and all that's being squared. So we'll type that in the calculator, and I am left my I have left my really good calculator at school, so I'm using my old 83, so it's going to take me just a minute to type this in. And when you get that, you get the population, you get p prime of 10, I do believe to be 1,626.3, which we'll just round it to 1,626 in the case of this. And so what you can say is the population at 10 years is changing at a rate of 1,626 people per year, would be the units on that. Because your time unit is years, I do believe. And so it would be 1,626 people per year. That's what the rate is changing by at time equals 10. And all right. So put that in context with your answer. Make sure it's in context. The next one is a very challenging question. And it's challenging because it's got a units twist to it that's really challenging. So I've already kind of wrote out some of my work here to get this started with this. What you're basically doing is you're given a rate of change and you're asked to find the other rate of change. You're asked to find the rate that the sprinting speed is changing. So you're given this equation that relates sprinting speed to the mass of these lizards, or whatever it was. I believe it's lizards. This is another lizards problem. So what we need to do, we're given W prime is 0.03 grams per day, but because this is in meters per second, we need to have grams per second because we need to be consistent on our units, our time unit. Okay, this is given in days, this is given in seconds. And it makes sense that this is given in days because, of course, who wants to talk about the mass of lizards, how much it changes in a second? That's not practical. But we need it to be that way only for the sake of getting this problem correct. So we need to take 0.03 grams per day, and we multiply that by 1 day over 24 hours, because there's 24 hours in 1 day, okay, which we multiply by 1 hour over 60 minutes, which we also multiply by 1 minute over 60 seconds. So minutes cancel out, hours cancel out, days cancel out, and I'm going to get grams per second. That's using a dimensional analysis there. So we do all that, we get this. And so we type that in the calculator to figure out what's and when we do that, we get 3.472 repeating times 10 to the negative 7th power. That's a really small number, and it is in scientific notation. Your calculator, if you look at this, your calculator is going to give you 3.472 repeating time, and that E negative 7 means times 10 to that power, negative 7. Which makes sense because, of course, the weight or the mass of the lizards is going to change by an extremely small amount each day. That makes sense. Or each second, each second. I mean, it's changing by a small amount, relative even per day, but it's an extremely small amount per second. So this number makes sense. You always want to make sure the number makes sense. And then you're ready to just take the derivative of this equation right here. So you're ready to take the derivative with respect to time. So ds dt equals, we're going to derive this with respect to time. So what we do is we take and, we power rule this basically. So we take 1.2 times 0.3, that's 0.36. We lower the power by 1, that's going to be to the negative 0.7 power, times the derivative of w with respect to time, which we just found right there. So since we know that, we're just going to plug in. We're going to plug in dw dt. That's what we just found right there. And I'm literally just going to take and I'm going to take that answer as it's still in the calculator, and I'm going to multiply it by this. Oh, and we're given a W in that instant, aren't we? So yeah, I'm not going to finish this one for you completely because I did not write down the mass. But you need to plug in the mass right there, and I literally would just take that answer that you have right there from that line times this quantity, 0.36 times whatever the mass is. It gives you a mass at that particular instant. You need to use that mass in the problem. Look for it in the problem to the negative 0.7 power. Get an answer, and that's going to be your answer with those units. It's probably going to be in scientific notation like this. It's going to be a small number because the sprinting speed, of course, it's going to change by a small amount per second as well. It's going to be likely increase. Well, it just depends. I'm not going to say it necessarily is increasing, but it's just going to be, you're going to have to go through and actually be really careful. It's going to come out to be something in scientific notation. So just be aware of that. Okay. Hopefully that makes sense, and we'll get you on the right track to that. All right, after that, you have the number 5 and number 6, which are asking you to write about things. So number 5, it gives you x equals c as a critical point. So I'm just going to talk a little bit about these. Just listen, and I'll talk a little bit about these questions. So number 5, they give you x equals c as a critical point. Explain what the second derivative test allows you to conclude about the point at c. So you need to explain basically how you applying the second derivative test, the different scenarios of what could happen and what they explain to you about what's going on there. So when you go through and do that, of course, the second derivative test, you're taking the second derivative. That tells you concavity. And so if you do that second derivative test, explain in your answer, explain what it means when you get the second derivative to be positive, when you get it to be negative, and what that tells you about that critical point. Okay, what kind of extreme moment it tells you about. That's kind of where you're going with that. I'm not going to elaborate any more on that, but that's where you're headed with that. And on number 6, it asks you to, I think I spoke to you all about this one maybe. I can't remember in class. I didn't talk about number 1, by the way, because I did that one in class with you all. Both classes, I believe, asked about that one. So I didn't do that one with you all because both of you all asked for that one. But number 6, I think I also explained this one or talked about this in class as well. We really didn't get to talk about a half-life when we did exponential growth and decay, but this is asking you to explain the concept of half-life. So honestly, this is kind of a chemistry question. It's kind of weird to have it in math, but it's also math related. It gave you an example if a substance had a half-life of 3,000 years. So a half-life basically, just to make sure everybody understands, a half-life is the amount of time it takes for a particular substance to decay to half of its original amount. So we're looking at exponential decay with this. You're talking about how long it takes for that substance to decay away to where there's only half of what originally was there. So that's what you're talking about with that. Explain that in words, in your own words. Use the example to help you back that up. Okay? So that's 5 and 6, which are more written. Let's look at number 7. It's asking you to find, it's talking about a population, I believe. I don't remember. I think this might be lizards again. These people really like lizards for some reason, the ones that wrote these problems. I don't know what's up with that, but whatever. To each their own. Whatever tickles your fancy. So the limit of P of t as t goes to infinity. If P of t is this function right here, a nice little rational function again. So if I'm wanting to find this limit, this function, if I plug an infinity in this, I'm basically going to keep getting bigger and bigger values as the numerator approaches infinity. That's a quadratic function. As the numerator approaches infinity, quadratic functions go to infinity or to negative infinity. But since the leading coefficient is positive, this parabola is opening up. It's going to go to a positive infinity. Same thing with the bottom. It's opening up, positive infinity. So this is an infinity over infinity indefinite case. Okay, this is an infinity over infinity indefinite form. Okay, infinity over infinity. So we can use L'Hopital's rule. So we can actually do the limit as t goes to infinity. We take the derivative of the top. That's going to give me 24,000 t minus 10,000 all over 2t. Which again, now we've got linear functions with positive slope on both cases. So this is also going to go to infinity over infinity. This is another infinity over infinity case. So L'Hopital's rule again, take it to the hospital. L'Hopital's rule. So the limit as t goes to infinity. We take the derivative of the top, we get 24,000. Take the derivative of the bottom, we get 2. That's 12,000. That's a number. There's no longer a t in there. We can reduce that. We get our answer to be 12,000. So the limit of this function, the limit as t goes to infinity of this function is 12,000. So with that, that being the case, 12,000, that means that's what the population is approaching. And so the authorities made a claim that the population was increasing unbounded. So talk about that. Was that claim right or not? Use the math of what we just found out. We found the limit to be 12,000. Okay, so talk about that in terms of that problem and discuss that. You're asked to evaluate their claim. Okay. And finally, you've got this question number 8 where you're given a function and this is the stock value. And the company is saying that the stock value increases on the interval 0 to 3. So what you need to do is to determine that. And determine increasing and decreasing, that's using the first derivative. So take the first derivative. That'd be 3x squared minus 10x plus 3. When you take the derivative here, term by term. Doing that rather quickly, but it's just the power rule. Okay, and so when you do that, now you're going to find your critical points. So 3x squared minus 10x plus 3. We're going to set that equal to 0, and we're going to solve that. To solve that, you can do, there's a few different things that you can do. You can find the, you could maybe factor this. I'm not sure if it'll factor or not. I don't know. I think it will actually factor. Your A times your C is 9, and you want two factors of 9 that add up to a negative 10. That'd be a negative 1 and a negative 9. So that'll break down as 3x squared minus x minus 9x plus 3 is equal to 0. And so then you factor by grouping. Out of the first two, you can take an x. You're going to have 3x minus 1 there. And out of these, you can take a 3, and it'll be a negative 3 because you take that negative with. And that's going to be 3x minus 1 again. And so you get your two factors to be x minus 3 and 3x minus 1. So set each of those equal to 0. You're going to get x equals 3. 3x minus 1 is equal to 0. 3x is going to be 1. X is going to equal a third. And now we're going to do a sign chart using these critical points. And we're going to plug in test values for the first derivative. So we've got 1/3 and we've got 3. We need only to worry about the interval. Don't forget where we're working with here. If we'd gotten a critical point that wasn't on this interval, 0 to 3, we're only caring about this function from 0 to 3. So if we had a critical point that was not on 0 to 3, we would just throw that one out. Technically, the 3 being the endpoint, that's only going to matter so much here with this one. So we're going to plug in values. We technically don't have to plug in a value above 3 because we really don't care about what is it doing above 3 because our interval stops at 3. Okay, in a normal scenario, yes, you would want to figure out what is it doing over here. But in this case, we don't. So we're going to plug in our test points. We can use 1 and we can use 0 for that matter. Now, if I plug 0 into this function, I'm going to get a positive 15 because every term that has x is going to be 0. So I'm just going to get a positive 15. So that's positive. That means it's increasing between negative infinity up to 1/3. Or in this case, since we only care about starting at 0 and going, we really can say it's increasing from 0 to 1/3. Sorry, 0 to 1/3 because the first derivative is positive. Okay, we're plugging in these values to our derivative. So we plug 0, actually we plug 0 into the derivative. I plugged into the original function, but when we plug 0 into the original function, we're going to get, every term with x is going to be 0, we're going to get a positive 3, sorry. Positive 3. It's still positive though, that means the function's still increasing there. Then we plug in 1. If we plug 1 into this function, we're going to get 3 minus 10, which is a negative 7, plus 3, which is a negative 4. You're getting a negative value. So the function is going to be decreasing between 1/3 and 3. That's kind of alarming because we just the company is saying that the value is increasing on the interval 0 to 3. So tell me, is the company lying? Are they being ethical in what are they telling the truth? That's what you're going to determine there in your answer. So write out an answer to that one in your own words. Determine how truthful the company was with their claim using your math. Okay, hope this has been helpful. I will try to do a Google Meet tomorrow when I'm back in the school. And if you want to jump on and ask questions from the other part of the review, you're more than welcome to. I'm sorry I'm not able to be there today, but I hope that you all work hard and just continue to review for your final exam. And you can ask your sub, Ms. Stovall, questions if you have questions.